All right, let's get straight to it. The industry is undergoing a fundamental paradigm shift. We're moving from informational AI to action-oriented agents. And let's be clear, this isn't some incremental update. This is a change in the core capability of AI, moving from systems that passively provide data to systems that actively execute tasks. So what's the real distinction here? It's all about function. A traditional LML can parse a quarterly earnings report and summarize the key findings for you. An agentic system, on the other hand, can take that summary, identify underperforming sales regions, and then automatically schedule performance review meetings by tapping directly into managers' calendar APIs. You see the difference? The first is data retrieval, the second is end-to-end workflow automation. We can really break down this shift from information to action across three key vectors: the system's purpose, its output, and its inherent limitations. When you analyze these, you start to see the real engineering challenges and, frankly, the massive opportunities. Okay, first up, purpose. A traditional model's purpose is really just scoped to that prompt and response loop. But an agent's purpose, it's designed to execute against a high-level, multi-step objective. So instead of asking, what are the flights to Seattle, the directive becomes find and book the most cost-effective travel itinerary to Seattle for a 3-day business trip next week. It's about achieving a goal, not just answering a question. Second, let's talk about output. The output of a traditional model is basically an information artifact. Text, some code, a summary. The output of an agent, though, is a state change in an external system. We're talking about a database write, a financial transaction, maybe even a CI/CD pipeline trigger. The key here is that the AI is directly manipulating other software or hardware. It's creating a real-world outcome. And third, limitation. Traditional AI has always been hamstrung by what we call the last mile problem, right? The human in the loop has to take the plan and actually implement it. Agentic systems are specifically engineered to close that execution gap. They're designed to move from planning all the way to autonomous completion, seriously reducing the need for manual intervention. Now, this ability to act autonomously isn't some kind of emergent magic from the model itself. It's enabled by a very specific architectural pattern that extends the model's core intelligence. Let's really deconstruct this agentic architecture. Okay, so the central engineering challenge in building these systems is how you bridge that gap between the model's internal reasoning and its ability to actually interact with external systems. The solution lies in a framework that connects the model's intelligence to a set of very well-defined capabilities. These connections are implemented as what we call skills, which are, for all intents and purposes, just API wrappers. For example, if you provide an agent with a skill for the Stripe API, you've just given it the ability to process payments. If you connect it to the Twilio API, it can now send programmatic SMS notifications. Every single skill is a new tool in the agent's toolbox, expanding its operational range. And this, of course, leads to a whole new development paradigm. Instead of writing imperative code that dictates every single step, developers are now focusing on declarative programming. You define the agent's goal, you provide it with a set of tools via APIs, and you establish the operational boundaries. The agent then uses its own reasoning engine to figure out the optimal sequence of actions to achieve that goal. This quote really captures the essence of the shift perfectly. The developer's role is evolving, right? We're moving from being a scripter to being an architect of the agent's environment and its capabilities. This new programming model has, as you'd expect, given rise to a whole new ecosystem of tools and platforms. So let's take a look at the emerging tool chain that developers are actually using to build these agentic systems right now. If we look at the Google Cloud ecosystem, Vertex AI is really providing that enterprise-grade infrastructure for scalable production-ready agents. Meanwhile, AI Studio is optimized for rapid prototyping. Workspace Studio, of course, is focused on automating tasks within its native environment. At the same time, you've got open-source frameworks like LangGraph and Crew AI emerging for building these really complex multi-agent systems. The choice of platform here really comes down to your use case, scalability needs, and the level of control you require. The development of agentic AI obviously has some pretty significant strategic implications. So let's zoom out and examine the long-term outlook for this technology and what its impact on the industry could be. For the last decade or so, the focus has really been on building better assistants, tools to help us find information faster. The future, however, is about engineering autonomous agents. These are systems that act as our proxies in the digital world.
This is that fundamental shift from information retrieval to true task automation.
And this brings us to a critical point. As we delegate more and more autonomy to these agents, they're inevitably going to move from simple task execution to complex and sometimes even ambiguous decision-making. This raises a massive governance challenge. What new frameworks, what new safeguards and oversight models are required when we're not just delegating tasks, but we're actually delegating authority to an AI? Honestly, the answer to that question is going to shape the entire future of autonomous systems.